Alrighty, let's tangle with some vectors using algebraic addition of vectors. Take a look at the problem. A jet flies 575 kilometers due east. Wait, even before I go anywhere, I'm going to go ahead and do some drawings here. I'm going to, like normal, assume that up is north, down is south, over here to the left is west, and to the right is east. I know, imaginative. So right down here, starting point, and let's just say 575 kilometers. Looks like that. Okay. Then flies 1250 kilometers, 40 degrees north of east. Okay, so 1250 is about twice that, so I'm going to make my arrow about twice that size. 40 degrees, I'm just going to do a guess here, is probably, let's just say that's good enough. Let's continue east out here. Let's label that. Okay, what was the total displacement of the plane? Okay, so the total displacement, if we remember from the graphical analysis of vectors, if you have your vectors tip to tail, here's the tip, there's the tail, the next one, your resultant vector is going to be a straight line from the tail of the first vector to the tip of the last vector. So let's draw this here. Okay, amazingly straight considering that I didn't use a ruler. Okay, so this purple line right here, that is our resultant. This is our end product. This is the vector that we're looking for. Okay, well, if you take a look at that triangle, nice triangle, it's not right. There's something wrong about it. Not just kidding. So it's not a right triangle. So it's difficult to do the familiar geometry and the trigonometry on that. So it would be nice to have a right triangle. Well, if you take a look at this vector right here, here's the one. This thing is not a friendly vector. It's not on the x-axis or the y-axis. It's not behaving itself. So it's not a friendly vector. So we have to analyze that. If we could somehow know what its east component was and its north component, then watch this. So this is 40 degrees north of east, so that is made up of a component that is eastward, and it is made up of a component that is northward. So if you take a look at that, you would use some trig. There's a right triangle, yay. Right triangle right there. There's a right triangle. We could use trigonometry or geometry to analyze these parts, but wait, there's more. So if we look at this purple line and look at this big triangle, look, this 575 kilometers east, this component east, those together make up the eastward side of that resultant, and then the only northward side is right here. So these two lines, these two vectors right here, this vector plus this component of that vector, and this component of that vector makes up the east and the north component of that resultant vector. So yeah, we can do this. It just takes a few steps. First of all, let's take a look at this 1250 kilometer vector, and let's break it down to its eastward and its northward components. Well, if that's the angle we're looking at, the 40 degrees, this eastward, I'm gonna call it E, this eastward is adjacent. Okay, so to find this side, we're going to need the cosine function. So the cosine of 40 degrees, whatever that ratio is, that is equal to the adjacent, or E, divided by 1250 kilometers. Okay, cool, we can do that. Let's look up here. Well, this side is opposite of 40 degrees, so that's the sine function. Sine of 40 degrees equals, I'm going to call that N for north, north over 1250 kilometers. So let's start down here with east. Well, the cosine of 40 degrees is 0.766, 3 sig figs, Okay, then to get E by itself, this is just basic algebra, we multiply that 0.766 by 1250. 958. So the eastward component of this 1,250 kilometer vector is 958 kilometers. So E over here is 958 km. Okay, let's put a rectangle around that so we don't lose it in all this red hullabaloo. Okay, now let's take a look at this one up here. So 40 degrees, sine is 0.643. Equals N over 1250. $804. So N equals 804 kilometers. All right. 3 sig figs, 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 3, 3, 3, 3, 3, 3, 3. Okay, so there's north up there. Okay, so we're not finished, not by a long shot. So now we know all of the eastward components of this resultant, and we know the northward component. Let's come down here, just because I've got a lot going on up here. Let's come down here and redraw that. All right, come on, purple ink, don't fail me now. Okay, so here's our resultant. That's what we're looking for. This northward component is 804. Eastward component is 575 plus 958. 1533. I just went from 3 sig figs each to 4 because I'm adding. Okay, and this is significant to the ones, significant to the ones, significant to the ones. Sig figs, I love sig figs, said no one ever. Okay, so let's take a look at this triangle right here. We have 1533 kilometers, 804 kilometers. We know that this angle right here is right. All's right with the world. So I've got two things to find here then. I need to know this angle. Let's be creative and call it theta. Ooh. I need to know that angle because remember, this is I'm looking for a displacement. So that has a magnitude and a direction. And I'm not an infant. I can't just say northeast. I can give that angle because I know how to do it. And then I need to know that magnitude. Okay? Well, the magnitude, let's start with that one first because that's just the Pythagorean theorem. We got 1533. We square that. Add that to 804 squared. Then whatever that sum is, we take the square root of it. Okay? I'm not going to do that out, but we get 1730 kilometers. Okay? Now, stop right here for a second. Let's check that for common sense. This is 1533, this is 804. We know the hypotenuse has to be larger than either one of these. Okay? Has to be larger than either one of these, but it's going to be smaller than these two added together. Okay? And this is 40 degrees, so if it's less than 45 degrees, it's going to be closer to the adjacent, and it is, than the opposite. So that seems crimelant. Is it correct? Who knows? If I did my math correct, it is correct. It looks like it would be correct, so we're good to go. And while we're just kind of common sensing stuff here, if this one's 40 degrees, whatever this angle is going to be, it's more shallow. So this angle right here, we know, we got a good idea. It's going to be below 40 degrees. It's going to be above 0, but it's going to be below 40. So if we do some calculations, if we punch stuff into the calculator, remember, this is a glorious invention. Now, this one's old, but like me, but it still works. This is a glorious invention, but it is nothing compared to the juicy magnificence of the human brain. Okay, so don't just regurgitate whatever comes out of here. Check it using your common sense. Make sure it makes sense. So we know this is going to be below 40 degrees. Now, if we take a look at this triangle, we have what is adjacent to this angle. We know the opposite of that angle, and we know the hypotenuse. So we could use whichever trigonometric function. Remember, we stick to the basic three. We could use either one of those, any of them, to find that any one of them. You know what? Since I have all of them, I'm going to use the sine because it's my favorite function, because whenever I write it, I get to write sin, and it makes me feel like a bad boy, rebel. Okay, so sine of theta, we don't know what theta is, equals opposite, this one, 804. Purple ink, come on, don't fail me. Divided by the hypotenuse, which is 1730 kilometers. And you know what? My theta is in green. I really should be using the green ink pen. Okay? All right, so how do I solve this? You know, most of you know that you plug in an angle and hit the sine button and you get the sine. But how do we solve this? Well, first of all, let's go ahead and find this ratio here. So sine of theta, you know, I switched over to green ink. Sine of theta, 804 divided by 1730 with 3 sig figs is 0.465. Okay, now remember, these units have gone away because sine is a ratio that is unitless, so that goes away. So how do we do this? Well, on an old-fashioned calculator like this one, you just punch in the 0.465, and then look here. See that little thing above the sine? It says sine to the -1. Well, what you're doing here is to get theta by itself, you have to divide both sides by sine, which is the same thing as multiplying by the inverse of sine. Well, that is sine to the -1. Okay, so once you have that 0.465, simply hit shift, inverse sine, boom. Okay, and we have 3 sig figs, so 27.7. So, does that fit what we thought would work? We said it was going to be less than 40. Cool. It's not really that much less than 40, but that would work. So, well, how do we write our answer? What's the total displacement? Okay, well, here's how we would write our answer. The airplane's total displacement is 1,730 kilometers, and that is 27.7 degrees north of east. There's our answer.